Hi, good afternoon everyone. My name is Vimal Kumar SathiyaBalan and this presentation for the 10th International Conference for Internet Technology and Secure Transaction ICITST 2015. And our title of the paper would be Study of Applicability of Chinese Reminder Theorem Based Group Key Management for Cloud Environment. I would really thank for our application Concordia University of Edmonton Information System Security Research Department and all the professors and throughout my research phase helpful from others and my family members. The introduction. The group key management was developed to restrict the access to protected assets only to the valid members in the group. The limitation of the recent study of these group key management schemes known as ACVBGKM and ABGKM requires high computation time for key update and key recovery process for the cloud environment. So we study the applicability from another algorithm called Chinese Reminder Theorem based group key management was developed for the multimedia cache environment to be switch over and apply for this selectively share documents from the cloud environment. As we introduction by the cloud environment, how it works. Here you can see the both environments here, cloud environment and multimedia environment. So let's start with the cloud environment works. First, the cloud users submit their identity attributes, which contains their attributes of what kind of user or age, another extra information to the data owner. Hereafter we call key server. So the key server finds matches with the identity attribute according to access control policy and policy configurations. And it delivers the secret key values to the cloud user. At the same time, the data owner compute and update the group key. When it moves to the fifth point, the key server selectively encrypt the uploaded subdocument using the group key, which is calculated, and upload to the cloud. Thereafter, it will be broadcast the group key as value to all the users. The valid users will derive the group key using their private keys, and thereafter the valid users will download the encrypted subdocument, and using the valid group key they can decrypt the subdocument. Once the user join and leave a single user, or it can be group, the key server will download the subdocument from cloud and recalculate using the algorithm to validate the new group key and upload again. So thereafter, whoever having the valid private key, they can decrypt the valid group key from the broadcast value. So as we said, the new algorithm what we suggested and felt it is really good from the cloud environment, from multimedia environment. The multimedia environment, how it works, as same as that. Here you can see the valid users, which is called the private users. They can submit their smart card values or their personal identification TV box number to the key server. The key server will match the smart card values and deliver the secret key value. Thereafter, it computes and updates group key and sends the group key content to the content provider, and the content provider will encrypt all the broadcast information according to the group key value. Only the valid users who is having the private key, they can able to receive all the broadcast information, all of the user, but only the valid user of the private key who can able to decrypt using the same algorithm can view the channels. So once any user leaves, like a batch of user for personal or private event, for like any Olympics games or any games, they can only subscribe the channel for a certain time, and they can obtain a new group private key value. Using the private key value, they can obtain a new group key value, and they can watch. Once they're done, the private key value no longer to be validated to get the new group key value. So as we discussed before, in a cloud environment there is two algorithms called ACVBGKM and ABGKM, which has the mathematical notation of ACVBGKM going to be order of n and ABGKM going to be in order of n for the hash values for the key server side. But the multimedia environment uses called CRTGKM algorithm, which is only having order of only one time, which is able to perform faster than these two algorithms. If we can have a look closely for key server and the cloud server, the CRTGKM much more faster in the mathematical nodes. The only disadvantage with the CRTGKM algorithm is the storage value of the keys when it need to be calculated for the further when user or leaves and join operation. So as we discussed, how the CRTGKM algorithm can be applicable for the cloud environment. So we identify the criteria based on our studies, and it can be done for cloud environment. If we look closer, the criteria, we identify storage server, document management, and the general security requirements, and preserving privacy and communication mode, at last group key management. Most of the common things from 1 to 5 are having the similarity. When it requires the CRTGKM to move over the cloud environment, according to the best, what we found is our section 6 group key management. So if we can look closer, computation time and communication time, and the rekeying mode, and the security aspects, which is more efficient rather than currently what cloud environment algorithm has. As we found these three algorithms to test which has more efficient, we developed our test bed, our own Java platform oriented programs. Here you can have a close look about how this group key management has had better performance according to these three algorithms. When it comes for a key server side, the ACV-BGKM has approximately 16 1,600,000 milliseconds for 50 users when it comes to key computation time. For ABGKM, approximately it comes more than 900 milliseconds for 50 users when in the Java platform for key updation time or key computation time. But the CRTGKM still runs very least almost under 15 to 20 seconds, sorry, 20 milliseconds for 50 users. When you see the group key recovery time for all the algorithms now, the ICITST has 34 ms for 50 users and ABGKM has 22 users for 50 users. At the same time, CRTGKM has less than a second for 50 users. So according to our studies, we concluded the CRTGKM is more computationally efficient than other two group key management schemes. The experimental results obtained by using developed Java application demonstrate the superiority of the CRTGKM scheme to other two schemes in key updating and key recovery process for cloud environment. The proposed key management solution can be tested for appropriateness in environments with requirement on low CPU utilization like your handheld devices or any other platform. These are the references we used to study our paper and we come up with the results. The test bed was developed our team to show and replicate same algorithm by the performance from the Java platform. Thank you for your valuable time for this presentation, and if you have any questions, kindly please mail at vimalind@gmail.com, as well as our paper going to be published, or if you have any question, we can able to share our paper. You can go deeply to have more information. Thank you.